Hi, good morning. Welcome back. My name is Yap Chi Yuan. I'm your trainer for Today e-learning, and welcome back to Huawei Routing and Switching Elite Training. So this is a HCIE level. Today's topic we are going to discuss on Lan Layer 2. So let's start our first topic. Let's look into the forward of this topic. So today's topic we are going to look into the Layer 2 technology. And the technology we are going to look into including the fundamental on how ARP work, Proxy ARP. We look into the MAC, we look into the link aggregation, and we also look into the GVRP. And all these are all on the Layer 2. And the objective for this slide include understanding the Lan Layer 2. That will be your fundamental on your exam. Alright, so you need to know the theory on the Layer 2, the principle of it, the configuration, very important, how we can look into the configuration of Layer 2. And we also look into the troubleshooting, as well as what are the topic that is examinable in your HCIE level. Okay, these are some of the content. Again, we are going to look into the principle of Layer 2, the configuration, the troubleshooting, and the exam preparation. So let's first go into the topic here. The first topic we are going to discuss will be on the address resolution protocol principle. Then we will move on to the MAC address table principle, link aggregation, and GVRP. Now let's look into the ARP principle now. The first principle we are going to look into the ARP topic here is the Proxy ARP. Okay, then we are going to look into the Gratuitous ARP. Now first let's look into the Proxy ARP. And Proxy ARP we have three types. Okay, so we have three types of Proxy ARP. Now the main purpose of the Proxy ARP is to solve the network connectivity problem. So we have three problems with the three different scenarios. So let's look into the first scenario, routed Proxy ARP. Here I have a switch where this switch have two VLAN, VLAN 2 and VLAN 3. So they are being divided by two separate VLAN. So we have two separate broadcast domain. On the left here I have PC1 where I have an IP address of 1.1.2.1/16. Now this is the interface VLAN 2, which is supposed to be a default gateway. Now because we are using a Proxy ARP, the IP address for this PC is 1.1.2.1. There is no default gateway. Alright, so default gateway here is not being set. And on the other side, I have a VLAN 3, and in VLAN 3, I have an interface VLAN 3 1132, where I have 1131 as my host. Now as you can see here, 1121 and 1131 belong to two different VLAN, but they belong to the similar Layer 3. Alright, both of them belong to 1.1. So assuming that PC1 want to go to PC2, so instead of using a router, PC1 want to go to PC2 will use ARP because the source, which is 1.1.x.x, and destination 1.1.x.x, they belong to the same network. So instead of performing a Layer 3, they are going to perform a ARP broadcast. Alright, so for you to configure the routed Proxy ARP on switch number 1, we have to enable the Proxy ARP between two different VLAN. Now let me show you how this works. Okay, so let's jump right into my lab here. Now I have three switches, switch 1, switch 2, and switch 3. Switch 1, the entire network here is in the VLAN 2. So this client, let me show you the configuration, is 1.1.2.1, which is /16. You notice that I do not have a default gateway. So when I do an IP config, there's no default gateway, and this is my MAC address. And on switch 1, okay, let me show you here, display VLAN. As you can see that I have a VLAN 2 and VLAN 3. Alright, and there's no VLAN 3 here except for this is a trunk port. Okay, and over here I have the 0010, which is belong to VLAN 2. Okay, and I also have a switch 2 here. I have a trunk port. Okay, so both on the port number 1 and port number 2 is my trunk, and I have VLAN 2 and VLAN 3. And on top of that, I have an interface VLAN. So this switch is also a layer 3 capable. Alright, so it's capable on doing layer 2 and layer 3. So this is my layer 3 IP address, 1122 and 1132. And finally, I have here switch number 3. I have a trunk on Ethernet 002, and Ethernet 0010 is a VLAN 3. So let me show you here. Alright, so here I have the trunk port. Okay, that's my trunk port, that's port number 2, and that's my access port, that is port number 10. Right, so let me do a demonstration before I enable the ARP proxy. So client 1 is going to do a ping, okay, to client 2, where client 2 IP address is this one. Alright, 1131. So I'm going to do a ping to 1.1.3.1. And you notice that it fell. Okay, right. Now, am I able to ping to my gateway? So if I try to ping my gateway, yes, it's pingable. Now please remember that I do not have any gateway here. Okay, so just to confirm, I do not have any default gateway in this part here. Right, so for me to make it work, I need to go to the switch number 2. Let me go back into the system view. In my interface VLAN 2, I just enable the ARP proxy enable. And I go back into the interface VLAN 3, I do the same thing, ARP proxy enable. Okay, that's all I need to do for me to make sure that client 1 and client 2 can ping. So let me do one more time. I'm going to ping to the client number 3, which is 1131. Okay, 1.1.3.1. so if we can see that early on is unreachable. Alright, so you can see that now it's reachable. Now all because that I have enabled for the Proxy ARP. Okay, and when I look into the ARP -A, sorry, as you can see from here, 1122 is this MAC address, 1131, which is my destination on the VLAN 3, having the same MAC address. Now the reason is because that I'm using the ARP, or in this case a MAC, from the interface VLAN 2. Alright, so if I go back into the client 2, if I'm going to do a ping to 1121, you can see it's pingable, and I'm going to do a ARP one more time. ARP-A, you can see that is 1121 is this MAC address. Okay, and I'm going to ping to my gateway, in this case is 1.1.3.2. Alright, so I'm going to check the ARP. Alright, so again you can see that they are using the gateway here, but you do not need to configure any gateway because it will able to see the gateway through the ARP. So that is exactly how the Proxy ARP works. Now, even though Proxy ARP is actually quite easy to configure, the problem here is you are actually using an ARP and figure out how to go to your gateway. Okay, and your gateway is going to proxy between two different VLAN. So which means that you are going to use a broadcast for you to do that, and secondly is that security is not that secure in this case. Okay, so this is our first one here, which is the router proxy ARP. Now next we have the intra VLAN proxy ARP. Now for the intra VLAN, you can see that the VLAN is the same. Alright, so we have VLAN 2 and a VLAN 2. Even the network is the same as well. Now we are actually using isolate VLAN, alright, isolate features for us to isolating between two different VLAN. So we have to enable the intra VLAN proxy enable on the switch for this VLAN to able to see each other. And one final one, which is the inter VLAN proxy. This is where we are using the super VLAN to allow two different VLAN. You can see that this is a sub VLAN 2 and this is a sub VLAN
tree. So we are going to create a super VLAN in the switch to allow the communication to take place. And for this, we learned on earlier topic, we have to enable the inter VLAN proxy. Okay, so these are the Proxy ARP, so make sure that you understand about the Proxy ARP. Next, we are going to examine what we call the Gratuitous ARP. So let's look into the definition on what is a Gratuitous ARP. Gratuitous ARP enables a host to send an ARP request packet with its own IP address as a destination. So which means that if I have a PC, let's say this is a PC1 with 1.1.1.1/24, where I connect to a switch, and the switch connect to the network here. Alright, so I have a lot of other PC in this particular network. So we are going to send a Gratuitous ARP. And who is the destination? The destination is yourself. Now, why you want to do that? Now, the reason why you want to do that is because of these three reasons. The first is to check for duplicate IP. Now, especially when you are configuring the HCP, they are going to send out, alright, before you are going to set a IP address on this particular PC, you are going to check whether is there anyone in the network who are using 1.1.1.1. If let's say you do, then they are going to send back an error saying that it is a duplicate IP. Alright, duplicate IP. So that's the first thing, to check for duplicate IP. Now second, we have this called advertised new MAC address. So assuming that I have a new PC that connected to the switch, this particular computer is going to send out the destination as its own. The reason is because that maybe you have changed your network card, alright, to a new network card or new MAC address. So it's going to check and try to tell the rest of the network, saying that hey, I have a MAC address and my MAC address here is 1.1. My IP address is 1.1 with a new MAC address. Okay, so that's a second reason why you want to use a Gratuitous ARP. And third reason why you want to use a Gratuitous ARP is because that assuming that now you are going to use the GVRP, and I have a master and I have a slave. So the master and slave is going to connect into the network. So assuming that the master now failed, the slave changed from slave status to a master. Alright, so it's going to perform a Gratuitous ARP to the network, saying that hey, if you want to connect to my virtual IP, I'm the one who you should connect to me. Alright, so these are the three reasons why Gratuitous ARP is important. Alright, so let's look into the MAC address table principle now. Okay, so we are going to look into MAC address table, port security, and MAC address flapping. Now, I believe that most of you know what is a MAC address table at this level. Alright, so we have a dynamic MAC address, a static MAC address, which is the MAC address entry I'm referring to, and the black hole entry. Now, just to recap, when we do a switch, you notice that the switch will learn the MAC address on its own, alright, because of how when the host is connected, it will going to send a MAC, and this MAC is being captured and is learned dynamically by the switch. Alright, so it created by interface that learn the source MAC address. It has an aging time, and by default the aging time is 300 seconds. Let me show you here the lab. Okay, so if let's say I just go into the switch here, when I do a display MAC address, alright, currently I have no MAC address right now, and if I'm going to just do a ping from 1121, I'm going to ping to 1131. Okay, so it's pinging. Switch to display MAC address. As you can see that it learned on its own, and you can see that it's dynamic. Okay, and we also can see that the dynamic learning here, the aging time. Alright, so the aging time is 300 seconds, and definitely we can change this value if you wish to. Alright, so if let's say we look into the other one here, which is the static entry. Now, static entry is manually configured and delivered to each interface card. It does not age. Now, reason why you want to do that is for security purpose, because you do not want to use the ARP to learn the MAC address. Instead, that you configure it statically. The drawback definitely is if you change your MAC address or your MAC address, or in this case your NIC card, where you have a static MAC address change. If you change the network card, then you have to update your switch. So if we can just go back into our switch here, I just show you how you can configure the MAC address static. So what we need to do is just to do a MAC address. You can see that we have a static keyword here. Okay, so we just set a static, then followed by the MAC address. Let's say I have a MAC address of this format: quad A, quad 1, quad 1. Let's say I'm going to do it on the Ethernet 001 with a VLAN 1. Okay, when I do a display MAC address, as you can see that I have this static MAC address here. Sorry. Okay, this is the MAC address that I created just now that have learned from 001, and that is a static. So this static do not have any aging time. Okay, so if you want to undo this, let me undo the term on first. Okay, so I just do undo MAC address followed by the AAAA quad 1. There you go. So display MAC address again. So you can see that it's gone. And lastly, on here we are going to look into the black hole entry. Now, black hole entry is more for security. Alright, so assuming that there are certain MAC address that you do not want them to communicate. Alright, so it's used to discard the frame with a specific source or destination MAC address. It's manually configured and delivered to each interface card, and it doesn't age as well. So let me show you this example here. I have a client 1 able to ping to client 2 as proven here just now. So let me do one more time. It's proven that I can do a ping here. So assuming that now I want to block client 1 from going to client 2. So what I need to do is I go back to switch number 2. So this is the MAC address, okay, 5489, okay, 6657. So I can double check from here. Alright, 6657, that's correct. So it learned from ARP. So what I need to do is just to do a MAC address black hole, and I'm just copy this MAC address here. Okay, that's about it. Alright, so that is a black hole. Display MAC address black hole. So I have one that is being black hole. Now just now you can see that it's pingable. Alright, so now I'm going to do one more time. As you can see that it's timeout because that this MAC address has been black hole. So assuming that now I'm going to undo MAC address black hole now, and I say that this one is for everything. Display MAC address black hole. So I already removed all the black holes, so now I should be able to ping back. Alright, so there you go. Alright, so this is the explanation on the MAC address. So you need to know that we have a different way of configure our MAC address. The default is always dynamic. You can configure statically, or for secure reason you also can do black hole. Now I believe that most of you know what is a port security is about. Alright, so here the port security we are learning in context of MAC address. So the port security function changes MAC address learned on a switch interface in a secure MAC addresses. Now what it means over here is by default when we learn dynamic MAC, alright, remember that it will age out, and by default is 300 Alright, so if you are configured as a port security, the MAC address will not age out and it's become secure. Now there are two ways for us to enable the MAC address. Alright, firstly is using dynamic, and secondly is using MAC address using a sticky. Now both of them will not age out. Now the only difference on the secure, dynamic and the sticky MAC address is when we use a dynamic port security, when you do a reboot of your switch, then the switch will not able to retain the MAC. Alright, so which means that once the switch restarted, you have to relearn on its own. I mean, whatever MAC address that is communicate on that particular port, the port that has port security will relearn the MAC address. Whereas for the sticky, when the first time you connect to the port with the MAC address port security sticky enable, it will be stick there. Alright, it will be sticky as its name suggests. So even though you do a reboot of the switch, it will not remove it. You do not need to relearn it. So these are the only differences between a secure address using dynamic MAC address and the port security where you have a sticky MAC address enable. Alright, so I can show you how this is being done. Let's just jump to our lab now.
Thanks for watching. Please do not forget to subscribe to our channel.